So, you're trying to fast-track your CCNA, right? Or maybe you're prepping for that big network engineering interview? Well, you are in exactly the right place. We're going to cut through all the noise and focus on the absolute core concepts you need to know. Not just to pass an exam, but to really build a solid networking career. So, what are those must-know skills? We've boiled it down to 6 core competencies that are, frankly, non-negotiable in today's world. Think of this explainer as your personal career toolkit. It's designed to help you nail the exam, ace your interviews, and, most importantly, solve real-world problems. Getting a handle on these 6 areas will absolutely set you apart from the crowd. Here's our game plan. We'll kick things off with IPv6, how devices get addresses on the modern internet. Then, we'll dive into keeping the network up and running with high availability, and how to automate key services with DHCP. After that, we'll see how to connect our private network to the public internet using NAT, lock down our traffic with ACLs, and finally, wrap it all up by adopting a crucial security mindset with AAA. Let's get into it. First up, IPv6. And let's be crystal clear about this. This isn't some maybe someday technology. It's here right now. For any modern network engineer, understanding IPv6 is an absolute must. The internet has already made the switch, and if you want to stay relevant, you need to as well. So why is IPv6 such a huge deal? Well, it all comes down to a really simple problem. We completely ran out of public IPv4 addresses. For years, we got by with these clever little workarounds like NAT, but they were just band-aids. They were complex and kind of held back innovation. IPv6 solves this with an almost infinite number of addresses, paving the way for true, direct, end-to-end connectivity again. Okay, to really get IPv6, you have to think about it in 2 ways: what you need for the job and what you need for the exam. On the job, you need to know the purpose. A global unicast address, that's your device's public IP on the internet. Link local, that's for automatic communication just on the local wire. And unique local, that's for your private, internal-only network. Now, for the exam, you gotta memorize these prefixes. 2000/3 for global, FE80/10 for link local, and FC00/7 for unique local. Flashcards are your friend here. So how does a device just magically get its own unique IPv6 address? It's all thanks to this really clever process called modified EEY64. It takes the device's unique 48-bit MAC address, its hardware address, and expands it into a 64-bit interface ID. The logic is so cool. It just splits the MAC in half, sticks FFFE right in the middle, and then flips the 7th bit. It's this elegant little trick that makes auto-configuration work, and it's a huge concept for troubleshooting and for the exam. Okay, so our devices have addresses. That's great. But what good are those addresses if the path to the internet suddenly goes down? It's not enough to just connect your devices. You have to keep them connected. And that brings us to high availability, which is a massive priority for any business. Picture this. What happens if a user's default gateway router, their only path out? Poof, they're cut off from everything. That's exactly where First Hop Redundancy Protocols, or FHRPs, come in to save the day. Think of it like having an understudy for the lead actor in a play. Protocols like HSRP create a virtual gateway. If the main router goes down, a standby router instantly and automatically takes over. For the users, the show just goes on without any interruption. This is a huge deal in any networking job. All right, let's walk through the HSRP process, because this is a classic interview question. First, you put a couple of routers into a group and give them a shared virtual IP. That virtual IP is what you give to your clients as their default gateway. Next, the routers chat using hello packets to elect an active router, usually the one with the highest priority. Everyone else becomes standby. The standby router's only job is to listen for those hellos. If it suddenly stops hearing them, it knows the active router is down and it immediately takes over the virtual IP. It's simple, it's elegant, and it is absolutely essential. We just talked about keeping the network online, but think about all the manual configuration involved. Manually setting up every single client device is just not going to happen. This brings us to the idea of working smarter, not harder. Let's talk about automation, and specifically how the good old reliable DHCP protocol makes our lives so much easier. I mean,
Can you even imagine having to walk around to hundreds or even thousands of computers and manually type in an IP address, a subnet mask, a gateway, a DNS server for every single one? It's not just boring, it's a recipe for disaster. One typo and you're troubleshooting for hours. DHCP, the Dynamic Host Configuration Protocol, just automates that whole mess. A device joins the network, it asks for an address, and boom, DHCP hands it everything it needs to get online. Knowing this inside and out is a fundamental job skill. For any networking interview, you have to know the DORA process. It's the simple 4-step handshake for DHCP. It goes like this. Discover. The client shouts into the network, "Hey, is anyone out there a DHCP server?" Offer. A server hears it and replies, "Yep, I've got an IP address for you. How about this one?" Request. The client says, "Awesome, I'll take that one, please." And finally, acknowledge. The server says, "Great, it's all yours." Discover, offer, request, acknowledge, DORA. Knowing that process is half the battle in troubleshooting client connectivity. Okay, so we've got our devices online in our private network, and we know the public internet is out there. But how do they actually talk to each other? That brings us to our fourth essential skill, Network Address Translation, or NAT. This is the magic that bridges our safe, private, internal world with the vast public internet. To really master NAT, you have to speak its language, especially if you're on Cisco equipment. This table right here is your Rosetta Stone. So inside local, that's the private IP of a machine on your network, like Bob's PC. When it wants to go to the internet, the router translates that to the inside global address. That's your public IP. And the server it's trying to reach out on the internet, that's the outside global. Knowing these terms cold is absolutely crucial for both configuring and troubleshooting NAT. Now, NAT comes in a few different flavors. You've got static NAT, which is a simple one-to-one mapping. That's great for a public web server. Dynamic NAT is also one-to-one, but it pulls from a pool of public IPs. But the real star of the show, the one you are going to see 99% of the time, is PAT, Port Address Translation. You'll also hear it called NAT overload. This is the workhorse. It maps many private IPs to a single public IP by using port numbers to keep track of all the different conversations. It's the main reason we didn't run out of IPv4 addresses years ago. All right, so our traffic can get to the internet now thanks to NAT. But here's a question. Should we let all traffic just wander in and out of our network? Absolutely not. We need to be the boss of our traffic. And that's where access control lists, or ACLs, come in. The best way to think about an ACL is like a bouncer for your network. It stands at the door and decides who gets in and who gets turned away. Now, here is the absolute golden rule of ACLs. The most specific or restrictive statements should be at the top of the ACL. Why? Because ACLs use what's called first match logic. The router reads the list from the top down, and the very first rule that a packet matches, that's the rule that gets applied. The router stops right there. So if you put a broad deny all rule at the top, nothing else below it will ever get seen. Getting the order wrong is a classic way to cause massive outages or, even worse, major security holes. Building an ACL is always a two-step process. Always. First, you create the list itself. This is where you write out all your permit and deny rules. But, and I can't stress this enough, that list does absolutely nothing until you do step 2. You have to apply it to an interface. You have to tell the router which door to watch and in which direction, traffic coming in or traffic going out. Forgetting to apply the ACL is the #1 rookie mistake, in the lab and on the job. Don't let that be you. We've made it to our final and maybe the most important competency. We've talked about controlling traffic with ACLs, but what about controlling the actual people who manage the network devices? Security isn't just a firewall you plug in. It's a framework. It's a mindset. And the AAA framework is the absolute foundation of that security mindset. So what is this AAA thing? Well, it's a security framework that gives us a methodical way to control access. It answers 3 simple but critical questions about anyone trying to touch your network. Who are you? What are you allowed to do? And what did you end up doing? Understanding this concept is a huge green flag in almost any security-related job interview.
It shows you think about security in a structured way.
The 3 A's are super easy to remember and so powerful. First, authentication. That's the who are you part. We verify your identity, usually with a username and password. Once you're in, we move to authorization. This is the what are you allowed to do part. Are you a full admin or can you only run a few show commands? And finally, accounting. This is the what did you do part. It creates a log of all your activity, which is crucial for auditing, troubleshooting, and tracking down security issues.
And there you have it. We've covered the 6 core areas: IPv6, FHRPs, DHCP, NAT, ACLs, and the AAA framework. You now have the fundamental building blocks for a fantastic career in networking. So the real question is, how are you going to take this knowledge and use it to build the secure, reliable, and automated networks of the future?
And that is our fast-track tour through these core concepts. Thanks so much for diving in with us today. Remember, the world of networking is always changing, so the most important skill you can have is to just keep exploring, keep questioning, and above all, keep learning. We'll see you in the next one.